1. So for AI, we've been asked to find P intersection I. That means those that are in both P and I, so that's the letters T, A and L. Now in part 2, we're being asked to find P union I. That means they're in P or I or both. So we've listed all of the letters in Portugal and then the new letters from Italy being the I and the Y. Now part B, it says, is it true that I intersection X intersection F equals 0? So is it true that there are no terms, no members which are in both Italy and France? Well, that's not true because A is in both Italy and France. So the statement is not true as A is in both I and F. Question 2. So for part A, we've got to work out the value of m when t is minus 3. So we're simply substituting minus 3 into this equation. So just pop this straight into your calculator like this, and it will give you the correct answer. But just so we're clear, minus 3 squared means minus 3 times minus 3, which is plus 9. And 9 2s are 18. And secondly, minus 7 times minus 3 is plus 21, hence the 39. Now for part B, we've got to start off by multiplying out the bracket on the left hand side. So 4 times x is 4x, and 4 times 3 equals 12. Now we want to get all our x's onto one side and all the normal numbers onto the other, and it's a lot simpler to take all the x's over to the side which has got the greatest number of x's to start with, which on this occasion is on the right. So I'm going to take all my x's to the right, all my normal numbers to the left. So I'm going to start off looking at the x's, so I'm going to take away 4x from both sides, giving me 12 equals 5x minus 10. Then I'm going to add 10 to both sides, 22 equals 5x. Then I'm going to divide through by 5, so x equals 22 over 5, or 4 2/5, or 4.4. Now for part C, I've got to write down all the possible values of y. Now y is an integer, that means it's a whole number, and it's two things. It is both less than or equal to 3, but also greater than minus 2. So be careful here, we're reading from the middle, we're reading from the y, so we're reading right to left here. This is when y is greater than minus 2, and then as I said, less than plus 3. So that's minus 1, 0, 1, 2 and 3. So we've included a plus 3 as it's less than or equal to 3, but we have not included a minus 2 as we're greater than minus 2, and don't forget that 0 is an integer. Question 3. So how many rupees did Lynn get? Well, we've got £250. We need to turn it into rupees. So we're going from pounds to rupees. So you can see this is creating a bigger number. So we have to multiply by 97. 250 multiplied by 97, 24,250. Now for part B, we've been told that Lynn takes 4 500 rupee notes. So obviously the amount of rupees she's got to start with is 500 times 4, which is 2,000. And now we're converting from rupees to pounds, so we need to go from a bigger number to a smaller number. So we're going to have to divide by 93.5. 2,000 divided by 93.5 is 21.939 ... So our answer to the nearest pound is 21 pounds. Question 4. Now to find the coordinates of a midpoint, you need to average the x coordinates and average the y coordinates. So we need to average the minus 4 and the 1, and we need to average the 9 and the 5. So how do we find the average? Well, we add them together and divide by 2. Minus 4 add 1 is minus 3. Minus 3 divided by 2 is minus 1.5. And 9 add 5 is 14. 14 divided by 2 is 7. Question 5. So we're told that the probability that Astrid wins a game of chess is 0.3. She's going to play 20 games, so an estimate for the number of games she's going to win is going to be 20 multiplied by 0.3, which is 6. Now we're told for part B that the probability that she will lose is 3 times the probability that she will draw. So let's make our smaller one x, so let's make the probability that she will draw x. So the probability that she will lose is 3 times bigger than this, so that's 3x. So the probability she will either draw or lose is going to be 3x plus x, which is 0.7. Now what do we know about the probability of her drawing or losing? We know it must be 0.7 because the probability that she will win is 0.3. So the probability she will either draw or lose must be the rest to take us up to 1, which is 0.7. So we know that 4x equals 0.7, so dividing through by 4, x must be 0.175. So our probability of drawing, x, is 0.175, and our probability of losing is 3 lots of this, so 3 lots of 0.175, which is 0.525. Question 6. So we're told there are 6 batteries in a small packet of batteries. So let's just think about this for a bit. So if we've got one small packet, we would have 6 batteries. Say we had 10 small packets with 6 batteries per packet, we would have 60 batteries. So how are we converting from the number of small packets to the number of batteries? We're multiplying by 6. Now we're told we've got m packets of batteries, so how many batteries will that be in m small packets? Well, we need to multiply by 6, so that's 6m. Now the same with the large packets. We're told that there are 9 batteries in each large packet, so if we've got one large packet we've got 9 batteries. So for example, if we had 10 large packets we would have 90 batteries. To convert from the number of large packets to batteries, we're multiplying by 9. Now we're told we've got G large packets of batteries, so that must be 9G batteries. So how many batteries do we have in total? Well, it's going to be 6M plus 9G, and we're told this is what T is, the total number of batteries. So T equals 6M plus 9G. Question 7. So we've got to show that 7/12 plus 3/8 equals 23 over 24. Okay, so how do we add fractions? Well, we need to have a common denominator, and both 12 and 8 go into 24. So let's set up 24 as being our common denominator. So how do I convert 7 over 12 into something over 24? Well, I can see I've had to multiply my denominator by 2, so I'm going to also multiply my numerator by 2, 7 2s are 14. Moving on to the second term, how do I convert 3/8 into something over 24? Well, looking at the denominator, the 8 has been multiplied by 3 to become 24, so I also multiply my numerator by 3, 3 3s are 9. Now once I've got my common denominator, I can just add my numerators. 14 add 9 is 23, as I had to show. Now for part B, whenever we're dealing with mixed numbers, I recommend you start off by turning them into improper fractions. That's top-heavy fractions. So just focusing on the left-hand side, 1 2/3 is 5 over 3. Because I've got one whole, which is 3/3, plus another couple of bits, that's 5/3. And here I've got 2 wholes, so that's 30/15, plus 1 giving me 31. Or shortcut, 1 times 3 is 3, 3 add 2 is 5, 2 times 15 is 30, 30 add 1 is 31. Now once I've got my top-heavy fractions, when I'm multiplying it's the easy one, it's just top times top and bottom times bottom. So 5 times 31 is 155 and 3 times 15 is 45. I've then simplified by dividing top and bottom by 5, giving me 31 over 9. I've then converted this back to a mixed number. Well, I can get 3 wholes out of this, because 3 9s are 27, leaving me with 4 ninths left over. So 3 and 4 ninths, as I had to show. Question 8. So we're told that each interior angle of a regular polygon is 156. Work out the number of sides of the polygon. Okay. So in order to do this, we're going to need to work out the size of each exterior angle. Now an interior angle plus an exterior angle form a straight line, so they together must add up to 180. So if the interior angle is 156, then each exterior angle must be 180, take away 156, which is 24 degrees. Now the exterior angles of regular polygons always add up to 360. So when you add them all up, you end up with 360. So if we know that each of them is 24 degrees, and together they add up to 360, the number of exterior angles must be 360 divided by 24, which is 15. Now clearly the number of exterior angles is the same as the number of sides, so therefore 15 is the number of sides of the polygon. Question 9. So M, L and N share £420 in the ratio 4 to 5 to 3. So M to L to N, 4 to 5 to 3. Now that is 12 shares in total. 4 plus 5 plus 3 equals 12. So we need to share this £420 equally across these 12 shares. So what I've done here, I can see that this ratio 4 to 5 to 3 equals 12, and I need mine to add up to my 3 to add up to 420. So 420 divided by 12 is 35, so I have to multiply each of these by 35 to work out how much Manu, Liam and Ned get. So they get 140 divided by 175 and 105. Now equally, what I could have done, I could have done 420 divided by 12 to see how much each share is worth, and then multiplied that by 4 for Manu, by 5 for Liam and by 3 for Ned. Either way, this is the amount of money they get when they share out £420 in the ratio of 4 to 5 to 3. Now once this has been done, Liam then gives Ned £75. So let's take 75 away from Liam and pop that onto Ned. So once we've switched this £75 across, this is the amount of money each of them gets. Now we're being asked to express the amount that Ned now has as a percentage of the 420. Well, Ned has got 180 out of the 420, so to convert this into a percentage, we do 180 divided by 420, multiply this by 100, giving us 42.857%. So to the nearest whole number, that's 43%. Question 10. So part A, very straightforward. When you're multiplying, you add the powers. 8 add 7 is 15. Yet when we're dividing, we take away the powers. So g to the 12 divided by g to the 2 is 10 take away 2, which is 8. And of course 12 divided by 3 is 4. So that's 4g to the power of 8. So just be careful. You're taking away the powers as you divide g to the power of 10 by g to the power of 2, but that's still a division. The division requires you to take away the powers, and obviously this is just dividing normal numbers. 12 divided by 3 is 4. Now anything to the power of 0 is 1, so that answer should be 1. If you're in an exam and you can't quite remember, just make up any old number. Just do 7 to the power of 0 or 10 to the power of the 0 on your calculator, and just remind yourself that you should get 1. Now for part D, each of these two parts inside the bracket has to be to the power of 2/3. So we've got 27 to the power of 2/3, and also x to the power of 6 to the power of 2/3. Now you can just pop this straight into your calculator to work out this component, but alternatively, if you're trying to do it in your head, you're cube rooting 27, which is 3. because 3 times 3 times 3 is 27, and then secondly you're squaring it, 3 3s are 9. So this cube roots the 27 to 3, and then this squares that to 9. And then secondly, when you have one like this where you've got a power inside the bracket and a power outside the bracket, you just multiply these two together. So 2/3 of 6 is 4, or 6 times 2 is 12, 12 divided by 3 is 4. So we get 9x to the power of 4. Question 11. Now there are a couple of ways of doing this. You could have basically said that AB is one side of a right-angled triangle, BC is the side of another right-angled triangle, and therefore the diameter AC is you get from Pythagoras when you do 7 squared plus 7 squared, square root that would give you the diameter, and then you would halve that. Or alternatively, you can do what I've done, and I'm just looking at these two radiuses here, and again by Pythagoras I'm saying this radius squared plus this radius squared equals 7 squared. So 2 lots of radius squared is 49, divide by 2, and I get r squared being 24.5. So however you do it, you need to work out that r is the square root of 24.5. Now the area of the circle as a whole is obviously pi r squared, and that's pi times the radius squared, so pi times 24.5. And I'm just leaving that as 24.5 pi for now. Now I've been asked to work out the area of the total shaded region, so that's the circle take away the square. So that's 24.5 pi being the area of the whole circle, take away the area of the square, which is 7 7s are 49. That gives me 27.96 dot dot dot. So to the nearest whole number, that would be 28. Question 12. So before we can work out the interquartile range, we need to put these numbers in order. So just be careful as you place them in order. Now, I've started off by working out the median one, which is the middle one, which is 19. And then I focused on the 5 terms before the median and circled the middle one of those. So that's my lower quartile. And then secondly, I've looked at my 5 terms past the median and circled the middle ones of these, and this is my upper quartile. So to work out my interquartile range, it's my upper quartile value of 24, take away my lower quartile value of 15, giving me 9. Question 13. So in order to see which two are parallel, I need to work out the gradients of each of them, because parallel lines have the same gradient. So each of these I'm converting into y equals mx plus c format. So that one's already done for me. The one at the bottom just needs to have the 2 terms on the right hand side rearranged the other way around, so minus 2x plus 3. With line B, I've divided through by 2, so that's 3 minus 1.5x, and then pop the x term first on the right hand side, on the right hand side, so giving me minus 3 over 2x plus 3. And then here I've had to add the 2y to both sides, minus the 3, and then halve it, giving me y equals 2x minus 3 over 2. So the two lines which are parallel are line A and line C, because they've both got a gradient of 2. Now for part B, I've been asked to find an equation of a line. Now you can use y equals mx plus c and go and find the value of c, knowing a point on the line. I prefer to use this formula, the y minus y1 equals mx minus x1. I think it's simpler, and I also think it's really useful to get familiar with this should you go on to do A-level. So y minus y1 equals mx minus x1, where x1, y1 is any point on the line, and we know a point 1, 3 is on the line, so my x1 is 1 and my y1 is 3. 1 and 3. And then where m is my gradient, so that's minus 5 over 2. Now I think at that point there, oh no, we wouldn't have got full marks because they do specify the form they want the answer. So we do have to go all the way through to the end. So anyway, we've got to give the answer in this format where all the numbers are integers, whole numbers. So I think it's easier to sort out this division by 2 straight away. So I'm going to choose to multiply through by 2. So on my left hand side, that's 2y and minus 6. Now multiplying my right hand side by 2 undoes this dividing by 2, just leaving me with minus 5 to be multiplied by x and minus 1. So minus 5 times x is minus 5x. Minus 5 times minus 1 is plus 5. So again, taking care to get it in the format that the question requires, I've added 5x to both sides, I've added 6 to both sides, giving me 5x plus 2y equals 11. Question 14. So for part AI, I've been asked to write down the size of angle ACD. Now this is one of these circle theories where these two angles at the circumference are the same, provided they're in the same segment, so provided they're both above the line AD. So the answer is 52 degrees, and for the reason its angles at the circumference in the same segment are equal, or angles at the circumference are equal in the same segment. You must include the fact that they have to be in the same segment. Now for part B, write down the size of angle AOD. Well, this again is another one of the circle theories, the basic circle theories, that the angle at the centre is twice the angle at the circumference. So the answer is 2 lots of 52, which is 104, and the reason the angle at the centre is twice the angle at the circumference. Question 15. So we've got to show that this quadratic applies. So what's our way into the question? The bit of information we've been given is that the area of the trapezium is something. So that's what this question part A is all about, areas of trapeziums. So how do you work out the area of a trapezium? Well, you average the parallel sides, which is the 2x minus 4 and the x plus 5, and you then multiply this by its height of x plus 3. So to average these two parallel sides, we're going to add them together and divide by 2. So that's 2x minus 4 plus x plus 5 all over 2. And that simplifies down, the numerator simplifies to 3x plus 1. So we've got 3x plus 1 to be divided by 2, and this has got to be multiplied by the height of the trapezium. And what does this equal? This equals the area, and the area equals 60. So this equals 60. Now I think at this point it's easiest to undo this dividing by 2 at this stage. So I've chosen to multiply both sides by 2. So that's undone this dividing by 2 on the left, giving me 120 on the right. So at that point I've got 3x plus 1 to be multiplied by x plus 3, and that equals 120. So multiplying out the pair of brackets, 3x times x is 3x squared, 3x times 3 is 9x. 1 times x is x, and 1 times 3 is 3. Gather up your like terms in the middle, 9x plus x is 10. Take away 120 from both sides, and we've got the quadratic in the form that we had to show. Now for part B, we've just got to solve this. So I think using the formulae is simplest for this. So A equals 3, B equals 10, C equals minus 117. And then popping it into the formula, and bearing in mind we only want the one positive value, x is a length, that x has got to be positive. We get this value from our calculator, we reject the minus 8.130. And then, so this is the x value that we're using, so to 3 significant figures, that's going to be 4.80. Now, just a bit of exam technique. If you've got one of these calculators that allows you to solve a quadratic directly, that's great. I would use that. So go straight from A, B, and C to your two solutions here. But you want to show that you could have used the formula, so do make sure you write this down as a working. You need to show the examiner that you were prepared to use the quadratic formula, but I personally, rather than actually use the quadratic formula at this point, I would rely on my calculator to take me straight to the solutions. But you must include this working here. Question 16. So, fairly straightforward, I think. We're told the probability that it rains is 0.8 on Saturday, so the probability it does not rain must be the rest to take us up to 1, so that's 0.2. 0.8 add 0.2 is 1. These crocodile mouths will always add up to 1. Right, now we're told that if it rains on Saturday, the probability that it will rain on Sunday is 0.65. So given we've come along here, it's rained on Saturday, the probability that it rains on Sunday is 0.65, so that goes in here. And then obviously this is the probability it does not rain, so these two here have to add up to a whole, so this is 0.35 being 1 take away 0.65. And then finally we're told if it does not rain on Saturday, so if it does not rain on Saturday, the probability that it will rain on Sunday is 0.4. So this bit here must be 0.4. So this must be 0.6 because these two together have to add up to a whole, and 1 minus 0.4 is 0.6. Now for part B, we've got to work out the probability that it will rain on just one of these 2 days. So either it rains and then it does not rain, rains and then it does not rain, or it does not rain and then it rains. Does not rain and then it rains. So what probabilities do we pass going down these 2 separate paths? 0.8, 0.35 and 0.2, 0.4. Now it's got to rain and then not rain, so we're multiplying these together, giving us 0.28. Similarly, alternatively, it's got to not rain and then rain, so we multiply these together, 0.08. Now the question says work out the probability that will rain on just one of these 2 days. We don't care how that's come about, whether it's come about through this scenario or this scenario. Now when it's an or, you add them together, so 0.28 add 0.08 is 0.36. Question 17. So to differentiate, remember what we do. You first of all multiply by the current power, and then secondly you reduce the power by 1. So 3/8 are 24, and then reduce the power by 1 from 3 to 2. So 24x squared. On this second term, multiply by 2, so minus 3 times 2 is minus 6. Reduce the power by 1, so 2 becomes a 1. X to the 1 is x. And then minus 25x just becomes minus 25, because effectively you've got x to the power of 1 here, which you then multiply by, so 25 times 1 is 25. You then reduce the power by 1, so that becomes x to the naught. X to the naught is 1, so that's why it's 25 lots of 1, minusing that, which is minus 25. Now for part B, find the x coordinate of the point on C when the gradient is 5. Now what you've got to appreciate here is the whole reason we differentiate, the purpose of this is to find out what the differential is for any value of x. So working backwards, if we want to find the value of x when the gradient is 5, we set this differential equal to 5. So 24x squared minus 6x minus 25 has got to be equal to our required gradient of 5. So this is a quadratic that we've got to solve. So set it equal to 0 by taking away 5 from both sides. I've just tidied it up a bit by spotting that 6 is a common factor, so I've divided through by 6. And then this is a quadratic equation that I need to solve. You could use the formula at this point, that would be absolutely fine, but I've chosen to factorize it, so I'm looking for 2 magic numbers. The multiply make minus 20, the 4 times the minus 5, you add to make the minus 1, so that's 4 and minus 5. I've then split this middle term, the x term, into these 2 factors, into these 2 components, so plus 4x and minus 5x. So I've gone from it being a 3-term problem to a 4-term problem. I've then fully factorised the first two terms, which is this, and then fully factorised the third and fourth term, which is this, but bearing in mind I want the bracket to be repeated, so that's minus 5 lots of x plus 1. And then my final pair of brackets comprises the two components that were not in a bracket to start with, so that's the 4x and the minus 5. And my second bracket is the repeated bracket of x plus 1. So my two solutions are what make each of these brackets equal to 0. So my first solution is 5 over 4, or 1.25, and my second solution is x being minus 1. Question 18. So we've got to draw a histogram. Now the key bit with the histogram is this frequency represents the area of each bar. The area of each bar. Now the time is going to be the base of each of these rectangles. So what I've done first of all is just to work out the length of the bases of each of the rectangles. So 0 to 30 is 30, 30 to 90 is 60, and so on. So I've got the bases of the rectangles here. So this is the time. So this is the base of the rectangle. I know this frequency here is the area. So how am I going to work out the height of each of these bars, the frequency density? Well, we know to work out an area of a rectangle is base times height. So time times frequency density would be frequency, or working backwards, frequency divided by time gives me each of the heights gives me the frequency density. So I've just done this column divided by this column divided, so this column 1, which I've called it, divided by this column 2, gives me these frequency densities. So I've then chosen an appropriate scale to use as much of the graph paper as I can. I can see my biggest frequency density is 5, so that's why I've chosen this scale on the left. And then it's easy. This first bar is just 30 along and 2.0 up. The second bar is 60 along from 30 to 90, yet 4.5 up. This third bar is 30 wide, going from 90 to 120, and that's a height of 5. This fourth bar goes all the way from 120 to 240, with a height of 1.3, and my final bar goes from 240 to 300, with a height of 0.4. Looking at that, I think that bar there looks a fraction wide, doesn't it? I think we just need to bring that one in a bit to bring it on to bang on onto the 300. So that there is our final solution. Question 19. So I've chosen to break this kite down into two identical triangles, and I'm going to work out the area of one of these triangles, then double it to work out the area of the kite. So looking at this triangle on the left, and using the area of the triangle rule, which says half AB sin C, I've relabeled my diagram to tie in with the formula in the given formula sheet. So I've made my angle C and my two sides A and B, lowercase a and b. So I've made A 6.4, B is 9.7, and my angle C is 110 degrees. So substituting that into the given formula, we get the area of the triangle being 29.168 ... Double this for the area of the kite, so 58.336 ... And then correct to three significant figures, so 3 digits in total. That's 58.3. Question 20. So we're looking at speed. Now speed is distance over time, and we're being asked to work out the lower bound for the average speed. So we want the speed to be as small as possible. So when we're dividing to get the smallest possible outcome, we want to be dividing something very small by something very big. So we're going to take the lower bound of the distance, but the upper bound of the time. So the distance travelled is 63.5 to the nearest 0.5 kilometres. So to get the lowest bound, we go down half of this 0.5, which is 0.25. So 63.5 minus 0.25 is 63.25. And we want to divide this by the upper bound of time. Now the upper bound of time, given this is to one decimal place, it's going to be 45.85 minutes, but I need to convert this into hours, so I'm dividing this by 60 because I'm working in hours. So my time is going to be 45.85 minutes, but divided by 60 to convert this into hours. So I've then popped this into my calculator using that fractions button a couple of times. So the fractions button, that one third down on the left, that gives me 82.7699 ... So to one decimal place, that's 82.8. Question 21. Now I think this is quite difficult really, but I think what we need to do, we need to break it down into two triangles. So I've popped the line across from L to N, and then I'm going to work out the angle that we require, which is the angle M to L to P, M to L to P. I'm going to work it out in two bits. I'm going to work out angle X and then angle Y, and the two together are going to be my required angle MLP. So just looking at this triangle LNA, I'm going to need to know the length of this side to be able to work anything out. So I'm going to do that using the cosine rule, because for this triangle I know a side trapped angle side. I don't know a pair at all, so I can't use the sine rule. So 72 is my angle, so that's going to be my angle capital A using the cosine rule. So I'm making that angle A. That is then my opposite side, so unknown side A, and I'm making these two sides here B and C. So substituting into the cosine rule, I get my length A being the length ln equaling b squared 4.3 squared plus c squared 15.6 squared minus 2 times b times c times cos 72. And popping that into my calculator and square rooting, I get the length ln to be 14.845 ... So once I've got this, I can now work out angle x using the sine rule, because I do now have a pair. I've got this pair of a's. I've got that side and that angle. I need to work out angle x, but I know it's opposite side 4.3. So I can say sine x over 4.3 equals sine 72 over 14.845 ... So multiplying both sides by 4.3, then inverse sinning that, I get my angle x to be 15.990 ... Now similarly with angle y, I can use the sine rule again. I can say sine y over 13.7 equals sine 58 over my 14.845 ... Then multiplying both sides by 13.7 and inverse sinning that, I get angle y to be 51.502 ... So my required angle MLP being x plus y is 15.990 plus 51.502, which is 67.49 ... So 61.5 degrees to three significant figures. Question 22. So I have to express m to the power of minus a third in standard form. So m is this, so it's going to be this to the power of minus third. So I can apply the minus a third power to each of the components. So I'm going to have 8 to a minus third multiplied by 10, 9n to the minus a third. Now this 8 to a minus the third, I can just pop straight into my calculator to get 0.5. But if you want to understand why, we're really saying we've got 8, which is really 8 over 1 to a minus a third. To undo the minus, we need to flip this over, so it then becomes an eighth to a third. So we then have to cube root the top and the bottom, giving us 1 over 2, which is 0.5. So when we've got a power inside the bracket and a power outside the bracket, we can multiply these two powers together. And 9n times minus a third is minus 3n. Basically it's 9n divided by minus 3. So at that point I've got this answer here, 0.5 times 10 to the minus 3n. Now that's not yet in standard form. Standard form requires the first number to be between 1 and 10. So I'm going to have to multiply this by 10 to make it 5. So I've multiplied that by 10, which is 10 to the 1, but I can't change the number overall, so I've got to offset this multiplying by 10 to the 1 by dividing this second term by 10 to the 1. Now when we're dividing, we take away the powers, so that's going to be minus 3n minus 1. So our final answer is going to be 5 times 10 to the power of minus 3n minus 1. Question 23. So the first thing to note is I'm using the two formulae from the formula sheet at the front. So concentrating on the total surface area of this hemisphere, so that comprises the flat circle at the top, which is obviously pi r squared, the area of a circle, and the curved bit is going to be half the surface area of a football, of the whole sphere. So rather than 4 pi r squared, that's going to be 2 pi r squared. So our total surface area is going to be 3 pi r squared, and we're told that this equals 16 over 3 pi. So 3 pi r squared equals 16 over 3 pi. We can then divide through by pi, so the pi's cancel, and then divide by 3, so we get r squared being 16 over 9. If we then square root, we can see that the radius is 4 over 3. So now let's move on to the volume of this hemisphere. Now from the formula sheet, the volume of a sphere is 4/3 pi r cubed, so the volume of half a sphere is going to be 2/3 pi r cubed. But we've just worked out that the radius is 4/3, so that's going to be 2/3 pi times 4/3 cubed. Now 4/3 cubed is 64 over 27, so 2 times 64 is 128, 3 times 27 is 81, so that's 128 over 81 pi. Now we're being told that this is k times pi, so k must be 128 over 81.